and I head the geometry and computational design team at Week Studio. And today I'm going to be talking about augmenting design workflows. So for the people that is not familiar with our studio, we are a 250 people strong studio based in London, UK. We work across all scales, all programs and uses, and in any location. So we work globally and type of projects that may go from something as big as a part of a city to something as small as a perfume bottle. Now, why do we need to improve our design workflows in the studio? One of the reasons is exactly the fact that we work in so many different subjects. Each time we start a new project, we tend to always go back to the beginning, and as it's very little that we can find usually that we could kind of reuse. But also because we love ideas and we love exploring new ideas and more options. And so optioneering for us is a key part of our process. So imagine each time we get a new brief, we'll try to understand how we will deliver that from the start to the very end of the stage and ultimately to the very end of the project. But we'll very quickly start kind of working on ideas, so our first option will run very quickly and we'll try to revise the options as many times as we can, but we'll also learn a little bit from that part. We'll jump into the next one, another iteration, and another one. We may go back to the beginning, the one that we started from, or start from a completely new one. Again, learn a little bit more and move further. And as we move along, we will very quickly end up with hundreds of different options, and then still going back to each one of them and restarting the process over and over again. And so that doesn't mean that is a bad way of approaching the design. It's actually our way of approaching the design process, okay? But it forces us to think in how we can use our kind of resources and energy in the most efficient way to actually allow or enable us to go through these quick iterations multiple times in very short periods of time. And so with the years, we understood that we needed a team of people that kind of enable the rest of the studio to do this in the more kind of effective and efficient way. And that's why we started the geometry and computational design team, where we focus on the future of human-centered design, so in the very essence of the mission of the studio. But we explore technologies and tools and materials that can make this design and human-centered design possible. And we do that by working on projects. We do that by consulting on projects. We do that by researching on emergent technologies, but also developing our own tools. And finally, we do that by sharing our knowledge across the teams and across the different people in the studio. And to implement this, we have an amazing team of people, computational designers, specialists, and architects that help us doing that. And they work in slightly different ways. We have a smaller team of specialists that mainly focus on project consultation and research and development. And we have a slightly larger team of designers that work most of the time embedded in projects, and then part of their time kind of working with the computational design team in exploring emerging technologies and developing tools. So if we look at, for instance, their project work, their kind of daily life will look something like this. So we'll be working on optioneering, parameterization, rationalization, running quick analysis on projects, and of course prototyping and perfecting workflows or delivering workflows for the team to either implement interoperability into their design workflow or applying some other type of intelligence in the process. When we do consultancy on projects, we'll focus on more specific things like, for instance, environmental analysis, and we'll have people not only running a specific analysis for a project, but delivering kind of a wider range of environmental related kind of analysis or tools that we always implement across different projects. They may also be helping on rationalization and other design workflows by kind of landing on a project, quickly figuring out where the gaps are in their workflow and trying to implement something that the rest of the team can kind of put into effect as soon as possible. But we will also be consulting on XR, so anything that may go from VR, augmented reality, virtual reality, anything in between across multiple projects. When we do research and development, we will kind of trying to find real gaps and problems that need solving in the studio. That may be for either design workflows or different kind of part of our process that could be improved through kind of the development of specific technology. But we will also be researching on kind of what is out there, what is happening outside the studio, what are the emerging technologies that are coming up, what are the things that other people are doing, and what are the problems that they have. And we'll see whether we share them or we can kind of explore these technologies to actually aid our processes to become better in the future. And we'll try to ultimately develop these technologies in a customized way to help our own design workflows. And in knowledge sharing, we'll kind of use everyone's team to spread the knowledge that they have across the studio. And we'll not only do this internally, but we'll also bring people from external people to do talks or run workshops or do training for us, or we'll maybe joining kind of hackathons to explore problems together with other people and other specialists from outside the studio. And so when we apply these things, across projects, it may look something like this. But let's look at this in slightly more detail now. So, for instance, in project work, thinking on this project that we're working on at the moment in Jeddah for Central Museum, we have a very large facade, about 50,000 square meters of facade that we aim to look like what you see here. And so it's very material kind of based. And we love this approach in the studio. We love craft. Thomas himself being a maker, this is something that is very much in the kind of the essence of what we do. So we'll commonly start from kind of trying to exploring different material properties and trying to push these materials to the very limit. And we'll fall in love with something. We'll try to understand how we can produce this at slightly different scales. So first of something very kind of little to something that can grow at a one-to-one scale. But in this particular project, even this very large scale that you see here is still very little in comparison to the overall design. And so that forces us to go back to the digital tools and try to explore this digitally, not only from the kind of the geometry we want to achieve, but also from the materials perspective. How can we model these material properties in a way that may start to achieve the geometries we kind of envision? And if they don't, we may change the tool. And so we may flow freely from something like Grasshopper to Houdini in this case, until we find a solution that really matches our kind of design intention. But we will not only get to that point, we'll also try to understand how we panelize this thing or make them grow and apply to a building scale. And again, we'll constantly go back, review design, and restart kind of the process. Now, once we're happy with something that we can apply to a larger scale, we'll try to find more intelligence in the process to actually achieve this and ultimately build this. So finding the right patterns and repetitiveness in the system to not only apply it conceptually but actually in reality. So in our particular case for this geometry, trying to understand at a macro scale how this conical geometries may support a bidimensional pattern, making it 3D, going back to the model, understanding the three-dimensionality of each of these models, how they connect together, and ultimately how do they become real panels. In this other case, for instance, for the Hainan Performance Arts Center, I'm gonna talk a little bit about not only this amazing kind of shell that you see here, but mainly about what happens inside. So for each of the halls, we have to take into consideration acoustic constraint and understand how this kind of three-dimensionality that we love to explore may aid some of these acoustic qualities. But we don't do that only by kind of blindly jumping into the sculpting, but really thinking in what are the geometries that help or not, in this case, the acoustic. But we'll not stop there. We'll also try to take into consideration how much you see from the stage. And so when you understand the heights and the angles you need, you have to make sure that the person that is in front of you is not going to block you, but not for one seat, but thousands of them. So then we compile this kind of different constraints together as a parametric model, and we don't stop in our first image. We love exploring kind of different designs, and we can evaluate them and see whether one design performs better than other. Not only from, again, the visual and acoustic constraints, but actually as a whole, as a design. So the emotive part of this is equally important to us. So everything goes into kind of the same mix and is evaluated along the process. And so we also think again in the tactile side of this. Can we go back and simulate interior materials now, test them at one-to-one, finding the right tools to kind of quickly simulate these behaviors digitally, and then go back to kind of the physical world until we're happy with, let's say, this workflow working as a tool set that we can apply then to multiple design options and look for the most fitted design according to our own criteria. Or for this project in Canada, where this highly volumetric tower used the balconies as main articulation, let's say, and with a huge amount of variation for over 100 different kind of balconies. And so the question is, how can we, let's say, take our design intention and then reduce the amount of uniqueness without losing the uniqueness in the design? So how can we add repetitiveness in the design without losing this kind of amazing three-dimensionality of it and the interest? How can we go from over 500 different types to only 20? So in this case, what we've done is that we take the designs we like, we set up a maximum amount of different types we can have based on the brief, and then we turn them into blocks, and each one of them can now be developed in terms of their own design, but we can also apply them across the facade using just a very simple algorithm that is mainly coded. Thus, this grasshopper looks very lean, but it's more interesting what's happening kind of inside those C# components that you see there, but allow us to kind of quickly automate the process of applying any new design across different parts of the tower in a way that we can now have, almost 700 balconies with only 20 different types. When we do project consultancy, as I mentioned before, we mainly work on environmental analysis and XR. So I'm going to focus on these two topics today. And environmental analysis, in the scope, let's say, for different types of analysis, we going from, let's say, site analysis to design analysis to validation. We mainly focus on the first two. So we work on understanding our sites and then understanding our designs quickly, early in the design process. And then when we develop these designs, we most of the time, if not all the time, we team up with external consultants. But because we do this over and over and over, we are able to look at this process in a more holistic way. So when we look at the site, we run something we call the climate charts that tackle, climate information, weather analysis, basic sum paths, but also set out kind of a baseline out of comfort for every project, and takes into consideration, of course, as well, the kind of the wind conditions. But as I mentioned, because we're able to run this through multiple projects, multiple times per month, and through the year, and through multiple locations, we are able to quickly kind of grow something that is not only applicable to one location or project, but through multiple locations, and hopefully aiding multiple projects in something that it's becoming an atlas for us. When we understand how our designs perform, so not only our sites, but our designs perform the second kind of a stage of analysis, we traditionally run solar access analysis, daylight, and solar radiation. So these things are kind of our common analysis that we run for every single project. But we also run wind analysis and thermal comfort for everything we do. So we not only look at this from our kind of from let's say the surrounding environmental kind of side, but also from the user kind of experience side as well. When we do XR consultation, we do it in multiple ways. We do augmented reality on site. We have a HoloLens that we usually use with Hologram and Rhino, and we take it to site to understand how our design performs on real scale. So bringing the real scale into the process is key, and augmented reality helps us to kind of move away from the scaleless environment in your screen to something that you can compare with your body, with the context, with the kind of the real world. So you are seeing here an example in Olympia, London, a project that is going up at the moment, and then UCB, a project in Surrey, which is also under construction on both sides, applying kind of AR technology. During our design process, again, using AR to understand kind of the real scale of things. You see Thomas here while we were designing and the aero car, but also trying to compare, bridging the gap between kind of the digital and the physical, right? So here we're holding one physical prototype against a digital projection of another option, and we can clearly see, the difference in scale. So like, okay, well, we may have to rethink the size of this. Something that in the screen may look just fine. For making, again, using AI, just to guide the drilling vectors, something that is not kind of easily documented in 2D. So using this as just as a guide to, let's say, to trace in 3D something is amazingly useful to put together kind of complex structures. We also work heavily with game engines, and in this case, we're looking at Unreal here, and we try to heavily customize our styles. So we're not using kind of out-of-the-box software, but we're kind of hacking it in a way that represent our own kind of needs. And we not only work with these softwares in isolation, we work on the workflows to interoperate between our preference design software, let's say Rhino and Grasshopper, to control and visualize quickly through kind of Unreal. And we also do VR for collaboration. So we're using spaceform technologies to collaborate between designers and do things like not only walk around projects, but kind of commenting in live sessions inside our own design. Finally, when we do research and development in the studio, we not just jump into any kind of technology that may sound exciting, but we really try to focus on real gaps and problems that we see across projects or in our design processes. And mainly we try to focus on things that will not aid the specialist work, but rather everyone else's work. So we really focus on tools for non-specialists. A good example of this, it's our Heatherwick tools in Rhino that implement many different BIM processes into our design workflow. And so, for instance, allow you to quickly have a massing model, add the levels to it, work with these levels in different ways, for instance, using them to navigate your model. So you can go to a specific floor, see how these kind of different levels may look like, even setting your plans to your working plans to work on them, or adding more data. So here we're seeing how you can add parameters to geometry. That in this case is the program, but it can be any text or any piece of information or data you may want to kind of customize as a new parameter. Now you can take your massing and run something we call massing that will take your massing and your levels and will kind of quickly give you your floors. It will inherit any data that you put into the massing. So here, for instance, is giving you the program already, and it's going to allow you to add more. So, here we modify something, we can say it's a modified floor. So anyone else that can come here, click on any part of the geometry and understand what's going on. Because the data is live, we can also run schedule, for instance, and get the areas very quickly based on your geometry and any parameters you have added. But also have other kind of BIM tools, for instance, allows you to have sections in your model and then control not only kind of the orientation of them, but really help you in kind of understanding the design. You can combine them all and visualize in different ways. And with all this together, you can finally select any level you have in your project or sections that you have created, generate kind of a basic viewport, and then print it. So you can generate these translations between kind of 3D information and drawings very quickly, everything kind of from within Rhino. And I know I said that these tools are for non-specialists, but for the specialists, we also have a way to access this and hack this information. So all our tools can be accessed from Grasshopper where you can add more data, extract data, and then bake it back into Rhino. But also allows you to bring all this information to the next level. So when we develop this design in a tool like Revit, we can always make sure that we are calling back to the geometry and the data we inputted in Rhino. And again, this is all related to having kind of a live, continuous flow of information and data. Is not only geometry, and ultimately allowing everyone to have quick iterations of design. Similarly, we have worked on a series of environmental tools. So based on the tools that traditionally require a specialist to go to a project and run analysis, we have pre-packed some of these workflows into a Rhino plugin that lets you have a quick solar analysis setups, or shadow analysis, understanding how the sun works in your project, and giving you basic information similar to our climate charts. But these are things that we've been kind of developing for a long time now, based on kind of our past experiences. So we're moving from a specialized world to a non-specialized world. But that doesn't mean that technology ends here, right? So what is coming up at the moment and what's going to happen in the future is what really gets us excited, So what are these future workflows? For instance, one of them obviously is AI. But when we do AI, we don't do it in, let's say, out of the box way, but we try to do it algorithmic. Of course, we use tools as Midjourney and other tools that are available to anyone. But we try to implement this in a different way. So here we're not using Midjourney, but rather in integrating Stable Diffusion as an open source kind of technology, but directly integrated in our kind of Rhino workflow. So you can use your own massing in Rhino and then run multiple iterations, and also integrating some new technologies. This is already kind of a year old. This is implementing Dream Fusion 3D, so text to 3D, but implemented directly within Rhino. Early stages yet, something quite interesting. But it's all about using our own knowledge, right? So in AI, it's key to have information to start from. And in our case in the studio, we have many information, loads of images that we can use to start from, hundreds and hundreds and hundreds of thousands of images that we can use. And we've been training our own data set, something we're calling StableWidth. And at the moment, allow us to start from, let's say, amassing, and then quickly visualizing it in different ways that are custom to our own design styles, but also allow us to visualize this not in only one way, bidimensionally, but also in 3D in a very consistent way. And of course, it opens opportunity for us to quickly run through design iterations, get inspiration based on our own past experiences. So very much tailored into our own design. And it's not only about how things look, right? So we're also very interested in how we implement these AI tools in other kind of workflows. Here, for instance, with the BIM team, using Cody to access our BIM documentation. So if you want to, learn something new, let's say apply a filter or something that you don't know in Revit, you can quickly use this tool to get you to the right place. And so going back to our initial thought and mission, when we focus on the future of human-centered design, we're doing it through the understanding of these technologies and tools, and always through materials that make this possible, not only because we care about technology, but mainly because we care about the people that is going to do these processes and ultimately use the buildings. Thank you so much.